This question is all about taking logs to bases that are less than one. And because I'm quite familiar with it, it's on some exam boards specifically, but other times it just kind of there on the outskirts. But basically, if you take log to base a half in this kind of situation, you actually have to swap the sign around. And so if you know that, you can do this really quickly. The answer is going to be B. So the rest of the video is going to be like justifying why that is the case. Let's say I wanted to solve a half. I'll stick with a half. A half to the power of x is going to be greater than, say, 8. Now, one way of doing this question, this is how I always had to do logs because my calculator did not have any other base other than 10 and e when I was in school. So I always took base 10. And that's typically what people did in the early days as well with, that's what 10 was always used. They'd have tables of logs using base 10. But now we've got calculators that can do any base. It's great, but you sometimes actually you stumble across little facts like this, which I didn't even know myself until I started teaching. So if we took log to base 10 for both sides, it would be log of a half to the x, and I could bring the x down, and then that would be greater than log 8. Now, when I divide through by log of a half, that would end up being negative, and so I would see automatically to make it x is less than log 8 over log a half. So I would always be able to see, I just swap the sign around because I'm dividing by a negative. Now, if you instead take the same inequality, but this time we do log to base a half, then suddenly it'll just become x and log to base a half on the right. But for this to make any sense, like a link with the one on the left, we have to swap the sign around. And these two are the same. You get the same answer. Now, hopefully you're thinking, okay, I'm not just going to accept that, although there is a rule to just no. But why is it? And the reason we don't have to swap the sign around like straight away when it's log to base 10, and if this was a 3, we'd never end up swapping the sign around. But when I take the log, so I don't have to swap the sign around, because log is an increasing function for bases that are greater than 1. So log to base 10 will look a little bit like that. But if I suddenly try and draw, so that is y equals log to base 10, so log x. Now I'm going to compare this with y equals log to base 1 over 10 of x. I've just I've just done the reciprocal of the base. Well, in that situation, I could write that 1 over 10 to the y is equal to x by writing it in exponential form. And that would mean that 10 to the y is equal to 1 over x, from which I can then write down that y is equal to log to base 10, or just log, of 1 over x, which is then minus log x. It turns out when you flip the base around, you get a minus, which does make sense, because if you have 2 to the 3, it's the same as a half to the minus 3. We just put a negative in front, which means that our function is going to look like this. And it's hence a decreasing function. So when we take log to base a half, we have to basically take that into account. Here we are. And if this is bigger than this, then when you do log to base a half, it's going to swap around. The right-hand side is suddenly going to become bigger than the left-hand side. For example, if I find log to base 1 over 10 of 3, and let's say it was, it's probably going to become negative. It's going to be down here. And then I compare it with log to base 1 over 10 of 2, I can see that actually this one is bigger. So the same applies here. I've got 8 and I've got a half to the x. When I do log to base a half of 8, if this is bigger, then when I do log to base a half of x, it's going to swap around. This is now going to be smaller. So that's my justification. At the end of the day, it's one thing to just learn. I think it's quite hard if you've never seen that before to be able to deal with this question, but you'd have to look through and sort of question it. And you could, to be fair, like try a value of n out. So you could try one of the solutions actually, n equals 1. Now when you put it in, we're going to get a quarter over here and 1 over 32 to the 10 over here. So we can see straight away that that is not true. A quarter is greater than that. But if we then try it in the next line, you could just put n equals 1 in again, then it would be log to base a half of a quarter, because n is now 1. So half to the power of what gives a quarter? That is going to be 2. And then a half to the what gives us 1 over 32 to the 10. Well, a half to the power of, I think it's going to be 5 is going to be 1 over 32. And then I can times through by the 10. So actually it's going to be 50 over here. And I can see that actually, if the sign is kept the same, that suddenly it works. So that must be the mistake. Like somehow it was, when I put n equals 1 in, it didn't work here, but then it does here. So we could deduce it that way if you weren't sure of the rule. That's my recommendation. And actually we see that, in fact, we need to keep the sign the same so that n equals 1 was not part of the solution set at any point. Okay, well done.